Okay. Yes. I'm very eager to find out how we are faring in a changing world, as we've just heard from Priam. This is the third Passion for Knowledge Festival in which I have participated. And it's hard to believe, but each one has been better than the last. I would like thank very much the P4K staff for their excellent work in orchestrating the festival, with special thanks to Ricardo and Pedro. Of course, known to many of us, he's Super Pedro, and he keeps things spinning all over, all kinds of things. And now, my wife, Georgine, and I find San Sebastian so beautiful, and the people of this city are so warm, welcoming, and so generous. Thank you for your friendship and your wonderful hospitality. 4 days ago, we had the great pleasure of visiting the nearby town of Bergara, where tungsten, known as wolfram, was discovered in 1783. True to Basque tradition, a baker in Bergara created here it is, a delicious dessert to celebrate the discovery of tungsten. He made a chocolate cupcake, sprinkling sparkled sugar and so on. And of course, in the light, it glistens, and that reminds us that tungsten filaments have done so much for the light of our world. Now, I think you will find the video created by the staff of the Science Museum in Bergara about the discovery of tungsten quite engaging. So here it is, the video that they produced. Bingo.
Hoy, en nuestro programa Pedazos de Ciencia, te descubriremos por qué la ciudad de Bergara y nuestros pioneros forman parte de la historia de la tabla periódica. ¡Empezamos! Egunon, muy buenos días. Durante 2019, el mundo conmemora el 150 aniversario de la tabla periódica de los elementos químicos. Su primera versión se publicó en 1869 y fue obra del químico ruso Dmitri Mendelev. Unos 100 años antes, científicos del Real Seminario aislamos por vez primera el wolframio en nuestro Laboratorium Chemicum. Concretamente, fuimos mi hermano Juan José y yo. Pero vayamos paso a paso. ¿Qué es y por qué existe la tabla periódica de los elementos químicos? La tabla nos permite una visualización rápida de las relaciones entre los elementos. Estos se presentan en orden creciente de sus números atómicos, es decir, su número de protones. La tabla nos ayuda a observar, por ejemplo, que las coincidencias de valores implican una coincidencia de propiedades químicas. Mendeleev fue un crack. En su tabla dejó espacios vacíos, anticipando la existencia y las propiedades de elementos que más tarde serían descubiertos. La mayoría de sus predicciones fueron correctas. En la actualidad se conocen 118 elementos. son los componentes básicos de la materia del universo. Uno de los elementos que Mendelev ubicó en la tabla era el wolframio, que habíamos descubierto mi hermano y yo en Bergara. ¿Cómo lo hicimos? Pues mi hermano había estado en Uppsala, Suecia, asistiendo al curso de alta química del gran Torben Olof Bergman. Allí trataban de aislar un nuevo elemento químico de un mineral que llamaban tungsten. En Bergara, la Real Sociedad Vascongada de Amigos del País había puesto en marcha ya el laboratorio de química. Una maravilla, una joya con lo más avanzado de la época, diseñado por otro grande, el francés Louis-Joseph Proust. Y allí trabajamos mi hermano y yo. Venga a moler y calentar mineral, a enfriarlo, a volver a moler. Total que, en septiembre de 1783, conseguimos aislar el nuevo elemento al que llamamos wolfram. Aquello fue la bomba. Descubrimos el wolframio, cuando aún solo eran conocidos 24 elementos químicos. El wolframio ha sido indispensable hasta anteayer mismo para los filamentos de las bombillas. Pero la incandescencia está pasada de moda. No es sostenible. Ahora usamos tecnología LED, ya sabes, de bajo consumo. Hoy se sigue utilizando en un montón de aplicaciones. Por su dureza, termoresistencia y su conductividad eléctrica, es un componente esencial en herramientas, maquinaria y todo tipo de ingenios electrónicos. El descubrimiento del wolframio no sucedió aquí por casualidad, sino gracias al Real Seminario. Por cierto, sin ánimo de hacerme el chulo, bueno, un poquito sí, el Museo Laboratorium y Bergara en 2018 recibieron la nominación de Historic Site por parte de European Physical Society. Ahí es nada. Y ahora nos sumamos a la conmemoración del 150 aniversario de la tabla, con exposiciones temporales, conferencias, visitas guiadas. Visita en nuestra web. Oigan, y directo al paladar de nuestra sabrosa cocina, nace un dulce con sabor a ciencia, el Wolfram Gottschalk, para celebrar los 750 años de nuestra villa y el descubrimiento del wolframio. ¡Delicioso! Y dirán ustedes, ¿qué tendrá que ver el tocino con la velocidad? Estúdienlo, que igual hay alguna conexión. La ciencia y la innovación están en todas partes para mejorar nuestra vida. Puede que todos los elementos que hay en nuestro planeta estén ya descubiertos, pero nos falta por explorar el resto del universo. ¿Y si el próximo nuevo elemento de la tabla periódica está en Marte? ¿O más allá? ¿Serás tú su descubridor? Vamos, manos a la obra. Aquí nos tendrás siempre, dispuestos a colaborar en tus avances. Desde Canal Laboratorium, gracias por seguirnos. Vayas donde vayas, que la ciencia te acompañe. Ah, y ustedes cuiden del planeta, qué buena falta le hace.
Very nice. So, I thought you would like it. And now I will show the video of my talk of celebrating Mendelev. As you know, Mendelev created the periodic table, but he did many other things, only one of which I will mention on my video. He was indeed a great scientist. So go on with my video. The United Nations has proclaimed 2019 as the International Year of the Periodic Table of Chemical Elements, one of the most significant achievements in science. The periodic table was discovered 150 years ago by Dmitri Mendeleev. My talk today will have two parts. The first will be describing Mendelev's pursuit to become a professor and his attempts to organize chemistry for the benefit of his students. I will briefly examine the periodic table, including the super heavy elements made by the Freyhof lab of nuclear reactions in Dubna. The second part links to Mendelev's consulting for Russian petroleum industry, which had a major role in his career. That industry was one of the most important sectors of the economy, as it still is now. From geological evidence, he concluded that oil was not created from fossil fuel, but emerges from the vast pressure cooker within the earth. Since then, most Russian geologists hold that view. It was also taken up by Thomas Gold, a cosmologist, who published in 1999 a book titled The Deep, Hot Biosphere. That led me to suggest an experiment to test an aspect of that theory. As part of the 2019 celebration of the periodic table, the journal Science dedicated its February issue to this subject. It includes articles ranging from hard-won discoveries and the hunt for new chemical elements. The cover of the issue displays a plaque located in Bratislava, Slovakia, honoring Mendelev. In previous years, postage stamps of many countries have honored him. Here I show a couple. Before discussing this periodic table, I want to consider the incredible early life of Mendeleev. A fine biography by Mikhail Gordon is available. Dmitri was born in February 1834 in a small village near Tobolsk in Siberia. He was the youngest of 17 siblings. His father, Ivan, was a school teacher, but he became blind and died in 1847. His mother, Maria, then restarted her family's abandoned glass factory, but it was soon destroyed by fire. Mendeleev, at the young age of 13, had attended the gymnasium in Tobolsk. His mother was determined that her brilliant Dmitri would receive the education his promise deserved. In 1849, she took him, at age 15, across Russia from Siberia to Moscow. It was a laborious 2,000-kilometer journey, often on rides hitched on horse-drawn wagons. Alas, when they arrived in Moscow, the university did not accept Dmitri. Maria and Dmitri continued traveling another 650 kilometers to St. Petersburg to his father's alma mater. The Mendeleev family, poor now, relocated to St. Petersburg. In 1850, Dmitri entered the Central Pedagogical Institute, the main training college for high school teachers. He was given a small government scholarship. Soon after that, Maria died. He took her last advice as sacred. Quote, refrain from illusions. Insist on work and not on words. Patiently seek divine and scientific truth, unquote. After graduation in 1855, Dmitri qualified as a teacher, taking the gold medal for the best student of his year. But he had contracted tuberculosis, causing him to move to the Crimean Peninsula on the northern coast of the Black Sea. While there, he became a science master at the Simferopol Gymnasium. In 1857, he returned to St. Petersburg with fully restored health. In 1859, Mendelev secured a grant to study abroad for 2 years. Working in a laboratory in Heidelberg, Germany, he discovered that every gas has a critical temperature. If the gas is heated above that temperature, no amount of pressure can turn it into liquid. Also, he had the opportunity to take part in the first ever International Chemistry Congress held in September 1860 at Karlsruhe, Germany. The Congress settled a means to assign the relative weight of all elements, with the lightest known element, hydrogen, assigned as a weight of 1 unit. This crucial notion of relative atomic weight was essential for discovering patterns among the properties of the chemical elements. On his return to St. Petersburg, Dmitri took up a teaching post at the Technical Institute. He found that there was not a Russian textbook on modern organic chemistry. Desperate for money, he wrote a textbook, completing 500 pages in just a few months. He submitted it for a prize and won the prize. His students were also enthusiastic about its clarity. In 1865, he became Doctor of Science and achieved tenure in 1867 at St. Petersburg University. He took on the large lecture inorganic chemistry course, which he called General Chemistry. It led him to produce the definitive textbook of his time, titled Principles of Chemistry. It was destined to go through 8 editions. Moreover, the periodic table emerged from his organizing of his book. In February 1869, the 63 known elements each were identified by the relative atomic weights determined via the Karlsruhe Congress. His fledgling textbook was to be in 2 volumes. Volume 1, recently sent to the publisher, was mostly about chemical practice. He had treated only 8 elements: oxygen, carbon, nitrogen, and hydrogen, chlorine, bromine, iodine, and fluorine. His volume 2 began with the alkali metals, the sodium family, and alkaline earths, the calcium family, and noted the pattern of the halogens, the chlorine family. In thinking about the patterns among the elements, Mendeleev proposed a system of classification. What must have been considerable work, he sent a draft of a single sheet to the printers on 17 February 1869. This sheet was entitled An Attempt at a System of Elements Based on Their Atomic Weight and Chemical Affinity. It was printed in both Russian, 150 copies, and French, 50 copies, and sent off to many chemists. The information on this sheet was the essence of the periodic table. He put 3 question marks where he predicted elements that had not been discovered. Eventually, they were scandium, gallium, and germanium. Today, the periodic table is governed by the International Union of Pure and Applied Chemistry, IUPAC, they call it, IUPAC. Here I show a very large periodic table displayed at the University of California at Berkeley next to a standard IUPAC table. The numbers stand for the element's atomic number, Z, the quantity of protons in the nucleus of each atom. These positively charged particles, the protons, determine the number of orbiting electrons whose configuration is largely responsible for the chemical properties. There are no gaps in the Z number boxes for the IUPAC table up to Z equal 118. However, many heavy elements do not exist on Earth. The heaviest element found at any appreciable amount in nature is uranium, with Z equal 92. Beyond that, scientists must create new elements in accelerators, usually by smashing a beam of light atoms into a target of heavy atoms. If the nuclei of the light and heavy atoms collide and fuse, a new element is born. For example, element Z equal 101, named for Mendelev, was made at Berkeley in 1955 by bombardment with helium ions of the element of Z equal 99, named for Einstein. The super heavy element factory in Dubda has added several synthetic elements to the periodic table, including Z equal 118, the highest one we have till now, and named for Yuri Oganisyan. He and his team are now pursuing Z equal 119 and Z equal 120. Many varieties of periodic tables have been for fun. The Harvard Chemistry Department has posted one for vegetables. An American singer, songwriter, Tom Gayer, has celebrated the periodic table with his song, The Elements.
Here's a song I always get requests for, but I can't understand for the life of me why. It's simply the names of the chemical elements set to a Gilbert and Sullivan tune. I think the only reason I do it is to see if I still can. We'll try. There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, actinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. I left out one, actually. A new one was discovered since the song was written. It's called Lawrencium. So those of you who are taking notes can write it down in your programs. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium, manganese and mercury and molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium, tantalum, technetium, titanium, tellurium, and cadmium and calcium and chromium and curium. There's gold and californium and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, kryptonium, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered. Thank you. You may be interested to know that there is an older, much earlier version of that song, which is due to Aristotle, and which goes like this. There's earth and air and fire and water.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Okay. Coming to part two, I celebrate Mendelev's view of petroleum. He suggested that petroleum comes up from the depths and could be derived from metallo-organic reactions with water. He discounted oil emerging from fossils from rotting of plants and animals for millions of years. His view is compatible with aspects of the book by cosmologist Thomas Gold. Here I display some basic assumptions made by Gold and comments by Mendelev. In recent years, much evidence supports this presence of a deep biosphere distributed on Earth in both terrestrial and marine settings. Gold's book and Mendelev's views led me to suggest an experiment. It was carried out in 2004 at the Geophysical Lab at the Carnegie Institution in Washington, D.C. The study was specially designed to detect methane formation under geologically relevant conditions for the Earth's upper mantle. The starting materials were natural carbonate calcite, plus a bit of iron as catalyst and distilled water. These were loaded into a diamond anvil cell. High temperature conditions were produced by laser heating. High pressure in the cell was measured by use of a ruby fluorescence monitor. The temperature ranged from 500 degrees Celsius to 1500 degrees Celsius, and the pressure between 20 kilobars and 110 kilobars. Those pressures and temperatures correspond to depths below the Earth's surface, between 80 and 350 kilometers. Raman spectroscopy exhibited clearly the presence of bulk methane, shown by the CH stretching vibration of methane. The spectra also displayed a broad OH stretching of ice or liquid water. Moreover, very notable was the extensive bubble formation that accompanied decompression of the samples at room temperature. Further analysis indicated that the bubbles are predominantly methane. The bubbles of methane contributed at least a little to the Carnegie Institution launching in 2009 a deep carbon observatory. Now it has grown to a global community of more than 1,200 scientists from 55 countries seeking to, quote, understand the quantities, movement, forms, and origins of carbon in Earth, unquote. How much that is deserved to be celebrated today can be traced to Dimitri's brave and determined mother. Thank you.
Thank you. This brings us to the end of our part of Passion for Knowledge 2019. Thank you all come here. Georgine and I, along with lots of you, will look forward to the next Passion for Knowledge. Thank you.